Imagine accidentally executing a denial of service attack against your own company's domain controllers.
Oh, the absolute ultimate IT nightmare.
Right, just completely crippling the entire network in a matter of seconds. And all because you clicked dynamic instead of static in a single drop-down menu.
Yeah, that happens way more often than people want to admit.
It really does. So today, we are stepping into the training room. Our mission for this deep dive is to make sure you do not become that administrator, the one who nukes their own network from orbit.
Exactly. We are keeping you off the IT incident response wall of shame.
Exactly. So you, our listener, are stepping into the shoes of a candidate preparing for the CrowdStrike Certified Falcon Administrator exam, the CCFA.
It's a big deal.
It is. We are acting as your proctors and trainers today. We're taking this massive stack of source materials, official exam guides, Falcon 200 syllabi, policy configuration docs, and advanced Fusion SOR playbooks. And we're distilling all of it into a masterclass for you.
And honestly, the stakes for the CCFA are incredibly high, which is exactly why CrowdStrike explicitly recommends that candidates possess a minimum of 6 months of hands-on experience in a production environment before sitting for this.
Yeah, this is not just a vocabulary test, right?
Oh, definitely not. It is the foundational cornerstone of the CrowdStrike Falcon certification program.
Right.
Whether you eventually want to move into the certified Falcon Hunter role or, become a responder, the administrator certification proves you understand the operational mechanics of the platform.
I mean, you have to know how to build the engine before you can race the car.
That is a perfect way to put it.
So let's lay out the battlefield for you. If you are sitting down at a Pearson on VUE terminal, you are staring down a 90-minute clock.
Tick-tock.
Yeah, 90 minutes to answer 60 questions, and the passing score is a steep 80%.
Which is brutal. There is almost zero room for guessing.
None at all. You are going to be tested across 5 major domains. So rule configuration carries the most weight at 30%.
Huge chunk right there.
Then sensor deployment is 20%. Policy application is another 20%.
Hmm.
And then user management and host management, well, they round it out at 15% each.
And you really need to notice the distribution there. A full 50% of your score relies entirely on rule configuration and policy application.
Half the exam.
Half the exam.
Yeah.
Because it's testing your ability to orchestrate a defense. You are not primarily hunting threats.
Right. That's the CCFA role.
Exactly. Your objective is architecture. You configure the platform to silently block known malicious activity and, isolate the highly suspicious stuff. That frees up your hunters to look for the truly advanced, stealthy adversaries.
Before we get to those heavy-hitting policy domains, though, I feel like we have to talk about the architectural philosophy, the one that underpins, every single exam question.
The single-agent approach.
Yes, the single-agent approach. Because in legacy environments, system performance was just an absolute nightmare.
Oh, don't even remind me.
Right. You'd have one heavy agent for standard signature-based antivirus, then another completely separate agent polling for endpoint detection and response telemetry.
And they hated each other.
They hated each other. Then a third agent running periodic vulnerability scans, and maybe a specialized agent just for USB device control.
Yeah, and they all fought for CPU cycles, they required constant rebooting, and they frequently caused kernel panics when they conflicted. It was a mess.
So how does the Falcon architecture actually solve that agent fatigue?
Well, it deploys one lightweight sensor that operates in both user mode and kernel mode.
Just one.
Just one. That single sensor handles endpoint protection, EDR, IT hygiene, vulnerability management, and even identity protection, all of it.
And it achieves this without requiring those continuous reboots, right?
Exactly. Because the heavy lifting, the complex machine learning models, the massive threat graphing, that all happens in the CrowdStrike cloud, not on the local CPU.
So the sensor is basically a highly efficient intelligence gatherer and enforcer.
Yes. And because it operates at the kernel level, it has deep visibility into process executions, network connections, and file modifications long before the operating system even surfaces them to the user.
Which, from an administrative perspective, simplifies deployment immensely.
Immensely.
Which explains why sensor deployment is 20% of the exam. You are focused on getting that one sensor installed, ensuring it communicates with the cloud, and verifying it hasn't fallen to reduced functionality mode.
Right, RFM. which usually happens due to an unsupported kernel update.
Exactly. So let's move into user management, which sits at 15%. A common pitfall I see for candidates is assuming this domain is just about knowing where the Add User button is.
Oh, yeah. They think it's just basic IT admin stuff, but the exam will aggressively test your knowledge of role-based access control, or RBAC.
And API governance.
Yes. The principle of least privilege is paramount here.
So let's test that out. In the console, you have several built-in roles. You've got the Falcon Administrator, the Falcon Investigator, the Falcon Responder, and the Analyst. So the exam might present a scenario. Let's say an entry-level Tier 1 SOC analyst needs to view detections and see the process trees. But they absolutely should not be able to network contain a host or alter a prevention policy.
Makes sense.
If you assign them the Responder role instead of the Analyst role, what specific UI capabilities did you just accidentally hand them?
Oh, that's a dangerous mistake. If you assign the responder role, you just gave them the keys to real-time response, or RTR.
Which means what?
It means they can now remotely access the command line of an endpoint, kill processes, and delete files.
Wow. For a Tier 1 analyst.
Yeah, a total disaster waiting to happen. The analyst role, conversely, strips those tabs away entirely.
The button just isn't there.
The RTR button literally does not render in their interface. They can view the telemetry, but they cannot execute destructive actions. And the exam expects you to know exactly which roles map to which UI elements.
And it gets even more granular with API keys, doesn't it?
Oh, absolutely. Building custom integrations requires generating an API client ID and a secret.
Let me give you a catastrophic real-world scenario, one that heavily echoes the logic of the exam questions.
Okay, let's hear it.
It involves API scope creep. Imagine an in-house development team building a script to automatically pull weekly detection metrics into a custom dashboard.
A pretty standard request.
Right. So the Falcon Administrator generates an API key for them. But instead of just checking the box for read access under the detection scope, they lazily check write access across the board, including prevention policies.
Oh no, I know where this is going.
Yeah. Then that developer accidentally commits the script with the hard-coded API keys to a public GitHub repository.
And within minutes, automated bots scrape those credentials.
Yeah.
And because the administrator granted write access to prevention policies, the adversary doesn't just read the dashboard data. They use the API to systematically disable ransomware protection across the entire host fleet before launching their attack.
It's terrifying. But the exam tests your ability to strictly define API scopes to prevent exactly this kind of lateral escalation.
Exactly, which actually brings us to the largest domain on the exam, rule configuration at 30%.
Right. And here's a question candidates always ask. If the platform utilizes native machine learning, autonomous threat intelligence, and systems like Charlotte AI to predict and block adversary behavior,
Right.
why is 30% of the exam dedicated to manual rule configuration?
They think the AI should just handle the heavy lifting.
Right. Shouldn't it just be plug and play?
Relying solely on the AI is a very dangerous trap.
Really? Why?
Because the machine learning models are trained on global, normalized threat data to recognize malicious behavior patterns. But they have absolutely zero context regarding the specific, highly idiosyncratic business logic of your enterprise.
Okay, let's break down the technical causality of that.
Oh.
We have to distinguish between an IOC, an indicator of compromise, and an IOA, an indicator of attack.
Yes, the exam will heavily test that difference.
So an IOC is static. It's a known bad file hash, a malicious IP address, or a command and control domain. If the sensor sees a known ransomware hash, it just kills it instantly.
Exactly. But an IOA focuses on behavior. It looks at the process tree.
For example.
Like, did Microsoft Word just spawn a hidden PowerShell window that reached out to an external IP? That is a behavioral IOA.
And that behavioral analysis is where human governance becomes critical. Let's use an administrative scenario for this.
So for
Say your enterprise has a deeply entrenched legacy HR application. Every Friday, it executes a custom, obfuscated batch script from a temp directory.
sounds suspicious already.
It does. It reaches out to a sensitive internal financial database via an SMB share, pulls down an encrypted payload, and writes it to the disk to process payroll.
See, to an AI model evaluating behavioral IOAs, that sequence looks identical to a stealthy lateral movement or a ransomware staging event. It is objectively suspicious behavior.
That is just payroll.
Right. But if left unconfigured, the Falcon sensor will kill that process and quarantine the batch file.
And then payroll fails and the entire business grinds to a halt.
Exactly. And the CCFA exam tests your ability to tune the instrument. You have to investigate that detection, verify the process tree, and then create a custom IOA exclusion.
So you're basically telling the sensor, hey, when this specific process executes from this specific directory and exhibits this exact behavior, allow it.
Yes, you are mapping the global AI to your localized reality.
Which brings us to the beating heart of Falcon administration. And this is our first major deep dive objective for this session. We're going to spend some serious time here, mastering prevention policy precedents.
Yes. If you take nothing else away from this deep dive, lock in on this section right now.
A prevention policy is basically the master document that dictates exactly which ML sliders are turned to aggressive, which behavioral IOAs are set to block versus alert, and how the sensor interacts with the OS.
But before you even assign a policy, you have to understand the deployment philosophy.
Right, the 3 phases.
The documentation mandates a strict 3-phase deployment approach for new customer environments. Phase 1 is monitor only, or coexistence. Phase 2 is enhanced protection. Phase 3 is full protection.
So the mechanics of Phase 1 often really confuse traditional IT admins. Because you are deploying a world-class security sensor, but the Phase 1 policy actively configures the sensor to take 0 preventative action.
Right, it doesn't block malware, it doesn't kill processes.
Furthermore, the documentation states you must run Phase 1 alongside your existing legacy antivirus. I hear people say all the time, why spend the money on CrowdStrike just to put it in passive mode?
It is entirely about baseline discovery and risk mitigation. Think about it. When you deploy a kernel-level sensor across 50,000 endpoints, the variables are just infinite.
Right.
Phase 1 buys you the minimum time required to observe the environment without breaking it. Because the Falcon sensor is so lightweight, it will not conflict with the legacy AV.
So during this, 15 to 30-day window, the Falcon sensor just watches everything.
It watches everything? It evaluates all the file executions and network connections against its ML models and generates detections in the console, but it lets the process run.
It gives the administrator a sandbox.
Exactly.
So you look at the console and you see a massive spike in critical alerts.
Yeah.
You investigate and realize 90% of those alerts are just that weird HR payroll script we talked about, or maybe a proprietary medical imaging software acting strangely.
Yes. And you use that Phase 1 period to write all your custom IOAs and file path exclusions. You clean up the noise.
And once the baseline is normalized, and you aren't seeing false positives, you move the hosts to Phase 2.
Right. You turn on the moderate blocking capabilities, and you finally uninstall the legacy AV.
Then eventually you advance to Phase 3, which enforces the most comprehensive, aggressive security posture across the mature environment.
But managing those different phases simultaneously across thousands of hosts is where policy precedence comes in. And this is a massive topic on the exam.
Right, because in a large enterprise, you will have dozens of custom prevention policies, some highly restrictive, some very lenient.
And because endpoints are grouped into host groups, a single server might logically belong to multiple groups simultaneously.
Okay, let's visualize the architecture here. Policy precedence resolves conflicts using a strict top-down list order.
Right, yes. The Falcon console reads your list of prevention policies, starting at priority number 1 and working its way down.
So the instant it finds a policy assigned to a host group that includes the specific endpoint in question, it applies that policy and stops evaluating.
Exactly. It completely ignores every single policy beneath it on the list.
I always think of policy precedence like an extremely rigid event security system.
Oh, I like that analogy.
Right. So attendees representing your hosts are wearing different colored wristbands, representing the host groups they belong to. Some attendees have multiple wristbands.
Okay.
The security guard at the door has a master rule list. Rule number 1 says, if you have a red wristband, you must undergo a full bag search and metal detector scan.
Strict.
Very strict. Rule number 2 says, if you have a blue wristband, you can just walk right in.
So what happens if an attendee walks up wearing both a red and a blue wristband?
Well, the guard reads rule number 1, sees the red wristband, applies the strict search protocol, and completely ignores rule number 2. The first match dictates the outcome.
This creates the absolute golden rule of Falcon administration. The concept you must burn into your memory for the CCFA.
Which is?
You must manually arrange your policies so that your most granular, highly restrictive policies sit the very top of the precedence list. And your broad, general policies sit at the bottom as a catch-all.
Okay, let's put this into a high-stakes exam scenario, because you know they will test this. Let's say you are the administrator for a global hospital network.
Okay, high stakes.
Very.
Yeah.
You have 10,000 Windows workstations scattered across dozens of clinics. You create a general Phase 2 enhanced protection policy. Is moderate. It offers solid protection, but has some necessary exclusions for older, clunky medical software.
Makes sense.
You assign this policy to a dynamic host group that automatically captures any machine running a Windows operating system.
A standard foundational baseline?
Exactly.
Right.
But deep in the data center, you have a cluster of financial billing servers. These servers process patient credit cards and highly protected health information. The regulatory compliance requirements are massive.
Oh, yeah.
So you create a Phase 3 full protection policy specifically for these servers. You turn every machine learning slider up to extra aggressive, you block all script executions, and you assign this ultra strict policy to a static host group containing only those specific billing servers.
Okay, so you now have two distinct policies, one broad and moderate, one narrow and aggressive.
Here's the scenario. A junior IT technician makes a configuration error. They accidentally apply an Active Directory tag to one of the critical financial billing servers that causes it to fall into the dynamic All Windows Workstations group.
Oh, boy.
Now, that highly sensitive server possesses two wristbands. It belongs to the billing server group, and it belongs to the general workstation group.
This is the exact moment precedence determines if the network gets compromised.
Right. So if you fail to organize your precedence list properly, like if you left that broad general Phase 2 workstation policy at the very top of the list, above your strict Phase 3 financial policy, what is the exact technical outcome?
It's bad. The Falcon platform evaluates the billing server as it checked in. It reads the precedence list from top to bottom. Priority 1 is the general Phase 2 policy.
Okay.
The platform queries the server, are you in the All Windows Workstations group? The server, due to the misconfiguration, says yes.
And then?
The platform immediately applies the moderate Phase 2 settings and stops evaluating. It never even looks at Priority 2. Your most critical financial server is now operating with weakened defenses, completely vulnerable to advanced scripting attacks, solely because the administrative list was out of order.
That is wild. So to fix this, you have to know the precise UI navigation path for the exam, because they will ask you how to actually rearrange it.
Yes, you do.
So you go to the left-hand navigation pane, you click Endpoint Security.
You select Configure, then you select Prevention Policies. And at the top of the policy list, you must click a specific button labeled Edit Precedence.
And once you engage that toggle, the UI changes. Draggable handles appear next to each policy. You physically click and drag your highly restrictive Phase 3 financial policy up to the Priority 1 slot.
Pushing the broad Phase 2 workstation policy down to Priority 2.
Yes. You click Save. Now, when that misconfigured server checks in, the platform reads the strict policy first, sees the match, and applies maximum security.
So study tips for you listening right now. Memorize that click path. Endpoint security, configure prevention policies, edit precedents.
And memorize that Phase 1 is for baselining, not full protection.
And just repeat the mantra. Granular and strict at the top, broad and lenient at the bottom.
But, having a perfectly ordered list of strict rules means absolutely nothing if those rules are guarding an empty room.
Right. You have to tell the Falcon platform exactly which endpoints belong to which policies. And if you get the host group assignment wrong, the policy architecture just collapses.
Oh.
Which brings us to our second major training objective. We need some real time on this too. Flawlessly executing host group assignments.
This basically bridges the gap between sensor deployment and policy application. So let me ask you this. When you push a Falcon sensor to a brand new endpoint before you've assigned it to any custom groups, what policy does it receive?
The platform falls back on the default policy. When CrowdStrike provisions your CID, your customer ID environment, it hardcodes a default Windows policy, a default Mac policy, and a default Linux policy.
So if a host is not explicitly matched to a custom host group, it just inherits the default policy for its respective operating system.
Exactly. And the exam will test you on a hard limitation regarding those operating systems. You cannot mix OS policies.
Wait, you can't have one policy for all of them?
No. The underlying kernel architectures of Windows, macOS, and Linux are fundamentally different. The Falcon sensor interacts with the Windows registry very differently than it interacts with Linux daemons.
That makes sense.
Therefore, the UI strictly enforces an OS split. A Windows prevention policy can only be assigned to a Windows host group.
So if you create a policy with custom IOAs designed to block specific PowerShell commands, and you try to assign that policy to a host group containing MacBooks,
the console will literally block the action. It won't let you.
Good to know. To move beyond the defaults, administrators use host groups. The platform offers two types, dynamic and static. Let's really explore the mechanics here.
Sure, so static groups are manual. You explicitly type in the host name or the exact CrowdStrike agent ID.
And if the machine's name changes or it gets rebuilt with a new ID.
It falls out of the group. It's rigid. Dynamic groups, however, use continuous querying. You build a filter. For example, local IP address starts with 10.5.x.x or Active Directory Organizational Unit equals marketing.
So dynamic groups are really the lifeblood of large-scale administration.
Oh, completely. As endpoints change IP addresses or as new laptops are spun up and joined to the domain, the Falcon backend constantly evaluates them against the dynamic filters.
And automatically shifts them into the correct host groups.
Yes, ensuring they instantly inherit the correct prevention policies without human intervention.
Okay, let me push back with an edge case scenario that trips up a lot of candidates.
Let's do it.
Let's say I create a dynamic host group. I set the filter simply to system manufacturer equals Dell. In my environment, I have Dell Windows laptops, but I also have a few developers running Dell hardware with custom Linux installations.
Okay, realistic scenario.
My dynamic group catches all of them.
Mm-hmm.
I then assign a Windows-only prevention policy to this dynamic group. Does the system throw an error, or does applying that Windows policy to the Linux machines cause a kernel panic?
Neither, actually.
Really?
Yeah. The system is designed to prevent administrative-friendly fire. When the dynamic group pulls in both Windows and Linux hosts, and you apply a Windows prevention policy, the platform's logic automatically filters by OS at the point of application.
Oh, that's smart.
Right. The Windows machines receive the policy. The Linux machines inside that same group simply ignore it, and they fall back to the next applicable Linux policy in the precedence list, or just the default Linux policy.
That is a crucial distinction. The group can be mixed, but the policy application is OS exclusive.
Exactly.
Now, we have to transition into the most advanced area of host group management. This is where we look at the integration with Falcon Fusion's SOR, security orchestration, automation, and response.
SOR is amazing. It allows you to build automated conditional workflows. If condition X is met, execute action Y.
It really elevates the administrator from just managing configurations to engineering automated defense mechanisms.
Yeah, you can trigger workflows based on detection severity, audit events, or even host lifecycle states.
The sources outline a highly specific, very strict rule regarding SR and host groups, though, specifically when dealing with on-premises infrastructure.
Yes, this is a massive exam topic.
You can build a workflow that says, if a critical EPP detection occurs, use an API call to tell our on-premises firewall to completely isolate this host from the internal network.
But the documentation mandates a hard limitation. If you use a SOR action that invokes an on-premises API, you are strictly forbidden from using dynamic host groups.
Wait, forbidden?
Forbidden. You must use a static host group. Furthermore, the best practices dictate that this static group must contain a maximum of 20 hosts. It cannot contain pods or containers, it cannot contain 32-bit platforms, and the host must have a response policy with real-time response, or RTR, enabled.
Okay, candidates often struggle with this because it seems so counterintuitive.
Yeah.
The entire premise of SOAR is rapid, fluid automation. Forcing an administrator to manually maintain a static list of no more than 20 host names feels like reverting to antiquated, manual IT practices.
I get that, but let's dissect the technical reality of why CrowdStrike enforces this. Let's look at the how. How does SR execute an on-prem API call?
Well, the CrowdStrike cloud cannot magically reach through your corporate firewall to talk to your internal routers.
Exactly. It uses the Falcon sensor itself as the conduit. The cloud sends a command down to the sensor via the real-time response channel, which is exactly why RTR must be enabled.
And the sensor then executes the script locally to hit the internal API.
Now, apply that mechanism to the DOS scenario you mentioned in our introduction. Consider the blast radius of what you are automating. We are not talking about automating a Slack notification here.
No, we are talking about automating the complete network isolation of machine via internal routing protocols.
Imagine you ignored the rule. You build your isolation workflow and apply it to a dynamic host group defined simply as operating system equals Windows server.
Okay, so your group contains every domain controller, every Exchange server, and every file share in the entire enterprise.
Then a vendor pushes a flawed software update. Or maybe the ML model throws a false positive on a legitimate administrative script, triggering a critical severity detection across all 500 of your Windows servers simultaneously.
Oh my God. Because the workflow is attached to a dynamic group, the SR engine executes instantly.
Instantly. It uses RTR to command all 500 sensors to hit the on-prem API and isolate themselves.
In a fraction of a second, you have severed your entire server infrastructure from the network.
The business doesn't just halt. It ceases to exist digitally. You have executed a perfect denial of service attack against yourself.
That is terrifying.
Exactly. Forcing the use of static host groups capped at 20 hosts is a mandatory failsafe. It requires the administrator to intentionally manually designate the specific targets for destructive automation.
It ensures you know precisely which machines are in the blast radius. You might use this for a highly secure enclave of 10 research workstations, but you cannot accidentally apply it to your entire shifting enterprise. So study tips for this section. Remember the OS split logic. And if you see a question about Fusion SO workflows interacting with on-premises APIs, the answer is always static host groups, maximum 20 hosts, RTR enabled.
They will try to bait you with a dynamic option on the exam. Ignore it completely.
Mastering policy precedents and host groups will absolutely secure a massive portion of your exam score.
Right.
But to clear that 80% threshold, you must demonstrate a holistic understanding of the wider Falcon ecosystem.
Because you are not just managing antivirus, you are managing identity, hardware ingress, and data egress.
Let's dive into identity protection, or IDP. Because adversaries today rarely bother trying to brute force a firewall or write custom malware to bypass EDR if they don't have to.
Why would they? They just buy compromised credentials on the dark web, log in via VPN, and walk right through the front door.
And to the EDR sensor, a user opening a file share and copying data doesn't look malicious if that user has the correct Active Directory permissions.
This is where the single-agent architecture shows its absolute brilliance. You do not need to deploy a new agent to monitor identity. You use the existing Falcon sensor, but you enable a specific feature called Authentication Traffic Inspection, or ATI.
Okay, but how does ATI actually work without functioning as a network proxy?
Because the sensor is operating at the kernel level, specifically when installed on your Active Directory domain controllers, it doesn't need to route traffic.
What does it do instead?
It hooks directly into the LSAS process, the Local Security Authority Subsystem Service. And it monitors the network interfaces. It performs deep packet inspection on the authentication protocols themselves, Kerberos, NTLM, and LDAP.
So it literally sits directly on the domain controller, watching every single ticket request and authentication handshake in the entire enterprise.
And because it observes everything, it establishes a behavioral baseline for every single identity. Let's say you have a service account used strictly for running database backups.
Okay.
That account normally only authenticates from the backup server IP address and only between 1.0 a.m. and 3:00 a.m.
So if the EDR sensor suddenly sees that service count attempting an interactive RDP login to a domain controller at 2:00 p.m. from a workstation in the marketing department,
The EDR alone might just see a standard RDP process, but the identity protection module sees the context.
it sees the massive deviation from the established behavioral baseline.
Yes, it flags the authentication as anomalous. And the CCFA exam tests your ability to build identity policies that react to this.
You can configure a policy that says, if a login attempt exceeds a specific risk score, challenge the user with multi-factor authentication before granting the Kerberos ticket, or outright block the authentication.
This seamlessly connects to another physical entry point too, Falcon device control.
Right. If identity protection guards the logical entry points, device control guards the physical ones. In older IT environments, stopping USB-borne malware meant physically altering the machines or using these draconian group policies that blocked all USB ports.
Yeah, preventing users from even using external keyboards.
Device control provides surgical precision using the same single sensor. The console allows you to distinguish between USB classes. You aren't just turning the port on or off.
Right. You can write a policy that explicitly allows human interface devices, or HIDs, like mice and keyboards, while strictly governing mass storage devices.
Let's look at how granular this gets for the exam. You can build a policy utilizing vendor hardware IDs.
Oh, yeah.
You can mandate that all USB mass storage devices are blocked across the enterprise, with one exception: a specific model of hardware-encrypted Kingston flash drives officially issued by the IT department.
So if a user plugs in a random thumb drive they found in the lobby, the sensor blocks it at the driver level before the OS can even mount the volume.
But if they plug in the approved IT drive, it mounts perfectly.
And you can modify the permissions dynamically. You can allow users to plug in generic USB drives, but restrict them to read-only access.
So they can copy a presentation off the drive, but they cannot write proprietary company data to it.
which introduces the critical distinction between device control and Falcon data protection. These two modules sound identical, but they solve opposite vectors.
Device control is primarily focused on preventing ingress,
Right.
stopping the execution of malicious payloads from untrusted physical media.
Exactly. Data protection is focused on egress.
Data protection analyzes the content of the files themselves. It looks for social security numbers, credit card data, or proprietary source code, and prevents that specific, sensitive data from leaving the environment.
Whether the user is trying to copy it to an authorized USB drive, upload it to a personal cloud storage site, or paste it into a web-based email client, as an administrator, you manage both the ingress vector and the egress vector through the exact same console UI.
The interconnectedness of these modules is really the hallmark of a mature Falcon administrator. Let's bring this all together by returning to Fusion SR for a minute.
Okay.
We discussed the strict rules for on-prem APIs, but the true power of Tire lies in its ability to automate the lifecycle management of the platform itself.
It really does. You can trigger workflows based on the host's first seen state.
What does that look like?
When a new laptop is provisioned, the moment the Falcon sensor checks into the CrowdStrike cloud for the very first time, SR can recognize that state, dynamically tag the host with its physical location based on IP subnets, drop it into an onboarding host group, and trigger a webhook to create an asset ticket in ServiceNow.
That saves so much time. You can also automate the remediation of sensor health.
Oh, yeah. If a host enters the reduced functionality mode state, meaning the sensor is running, but it's blind because a user updated to an unsupported Linux kernel,
SR can instantly remove that host from the general population network group and place it into an isolated remediation VLAN until the sensor is updated.
there is also a brilliant administrative workflow regarding content updates. The Falcon sensor constantly receives channel file updates containing the latest threat intelligence, but in highly controlled environments, you don't want updates applying during peak business hours.
Managing patch windows manually is a complete nightmare, but with SAR, you can just schedule a workflow.
You configure it to automatically modify your sensor update policy every Friday at midnight, shifting it from paused to enabled.
The sensors pull down the latest ML models and IOA definitions. Then, at 4 a.m., SOR modifies the policy back to paused before the business day begins. You literally use the platform to govern the platform.
So when you sit down for the CCFA, think of the Falcon architecture as a deeply integrated nervous system.
The EDR telemetry is the pain receptors.
The identity protection module is the cognitive context, constantly verifying if the signals make logical sense.
Device control and data protection are the physical barriers, the skin and bone. And Fusion SOR is the autonomic reflex, reacting to stimuli faster than a human ever could.
To succeed, you must understand how to control those reflexes. Remember the core directives. The single-agent architecture eliminates performance bloat but requires careful deployment.
Policy precedence is absolute.
Yeah.
Your most granular, restrictive rules must sit at the top of the list or they will be bypassed.
Host groups require meticulous OS segmentation, and you must strictly adhere to the 20-host static limit when automating destructive on-prem API actions.
And remember the purpose of the three-phase deployment. You do not turn everything to maximum aggression on day one. You use phase one to observe, to tune your custom IOAs, and to understand the unique heartbeat of your enterprise before you unleash the enforcement capabilities.
The exam will test your theoretical knowledge, but that 6-month experience recommendation exists because the reality of administration is messy. Theory tells you how to build a dynamic group. Experience teaches you the cold panic of realizing you just applied a strict blocking policy to a vital legacy server because your filter was too broad.
Yeah, that muscle memory is what separates a candidate from an architect. As we conclude this deep dive, I want to leave you with a profound operational reality to consider. We have spent the last hour dissecting how to configure policies to automatically kill processes, how to use SOR to instantly drop network blast doors, and how to rigorously control identity and device access.
It is an immense amount of automated power.
It is. But as the Falcon administrator holding the keys to the kingdom, your greatest challenge isn't the adversary. It's the balance. How you tune the aggressive machine speed automation of a system like SR against the catastrophic risk of accidentally taking your own company offline. If you set the AI to block every suspicious anomaly, you secure the network but destroy the business workflows.
And if you tune it too loosely, the business hums along right up until the ransomware detonates.
Exactly. The machine learning models cannot calculate the acceptable risk tolerance of your specific CEO. The AI cannot negotiate with the HR department about their legacy batch scripts.
Only the administrator can. You are the translator between the raw mathematical logic of the Falcon platform and the chaotic, necessary reality of human business.
Keep that balance in mind as you review your click paths and your precedence lists. When you sit down at that terminal and the 90-minute clock starts ticking, remember that you aren't just configuring software. You are engineering a resilient ecosystem. Good luck on your CCFA exam. You are ready to build the fortress.